So I'm here to just quickly introduce our speaker, and it's pretty impressive. Thank you for keeping the lights nice and bright here, but Eitel Lauria is a professor of data science and mathematics systems and the director of the graduate programs at the School of Computer Science and Mathematics. This school includes also the Masters of Science in Computer Science, the Software Development area, the Masters of Science in the Information Systems area, and the Advanced Certificate in Business Analytics. Professor Lauria has worked in the IT industry for many, many years and has served as a consultant for IBM, Microsoft, ExxonMobil, Reuters, Hewlett Packard, GE Global Research, and the World Bank, among many other global corporations. Dr. Lauria's research has been published in a number of prestigious journals, including the Decision Support Systems, the European Journal of Operational Research, the Journal of Learning Analytics, the Expert Systems with Applications, and the ACM Journal. He is the recipient of the 2015 Marist College Board of Directors Distinguished Teaching Award, and he has been at Marist for 21 years, we learned today at dinner. Professor Lauria was born and raised in Buenos Aires, Argentina, so he describes himself as an Argentino and a
Porteño.
So I knew you would say that much better than I would.
Exactly.
And in his spare time, he loves working and playing squash. We learned that also at dinner. He's a scuba diver, not a driver, and a former rugby player. It gives me great pleasure to introduce you to Eitel Lauria.
Thank you. Well, first of all, thank you for having me here. I'm a porteño. A porteño is someone who came through the port of Buenos Aires, as many immigrants in my country, basically. Buenos Aires is a large city, 8 million people. Greater Buenos Aires is like 12, 13 million people, so yeah, very large metropolis in a way. So I'm here today to talk about, or perhaps scare you about, I brought a bowl of Valium if you need me to distribute. But, this is a very relevant topic, and perhaps a good way to start. I'm a bit of a movie buff, perhaps that was not mentioned. I didn't put that in my bio, but perhaps a good way to start is here. If you remember, many of you probably remember this movie. My parents took me to see this movie, Stanley Kubrick, 2001, A Space Odyssey. It kind of blew my mind at the time. This is the eye, one eye looking at the astronaut Dave at the time and interacting in a way that looks pretty much the way in which, if you have gone into ChatGPT or any of the, let's say, multimedia large language models that we are interacting with, it has that feeling to a certain extent. And the question here is, how did we actually get here? Or are we close in any manner? Are we really interacting with HAL 9000 in the way in which this was happened? And if you remember a little bit about the movie, there were some very interesting possibilities. There was plenty of dangers also. So in a way, I thought it was a good way of bringing these two aspects of it together. So when we think in terms of how did we actually get here, perhaps a good way is to say, well, how did we actually started with it? So again, if you think in terms of the term artificial intelligence, this goes back to conference that was launched by a group of young computer scientists. At the time, John McCarthy, working as an assistant professor at Dartmouth College, thought it would be a good idea to create a meeting of minds, bring people together that could discuss the idea of intelligence, how intelligence could be mapped into something related to computing devices. He didn't actually want to use the term that was used at the time, which was cybernetics, and Norbert Wiener, a bit of the person that brought about the idea of cybernetics. He didn't want to use that term. He didn't want to bias the idea. And so he used a term, coined a term that was completely neutral, the idea of artificial intelligence. And so if you take a look, I mean, there are a number of very illustrious names over there. McCarthy, Minsky, Rochester developed one of the first IBM computers, 701. Claude Shannon, we owe him lots of things, but we would not have networking as we have it, and information theory without his work. But there were a number of other people at that conference. Herbert Simon, the first famous computer scientist that later on became a Nobel Prize in economics. Samuel actually wrote the first checkers program in 1959, and it was so successful that the shares in IBM jumped one day 15 points, which was completely crazy. And a bunch of other people, some notable absences. Von Neumann was very sick at the time. Turing had died a couple of years before. But this meeting of minds, although very productive in many ways, was also very ambitious. If you take a look at the statement there, they wanted to create this conference for about 2 or 3 months during the months of summer. And the idea was to see if they could actually abstract the idea of coming up with ways of making machines use language, form abstractions and concepts, solve kinds of problems reserved for humans. Well, it took a little bit more than 2 months. It was extremely productive. The term was coined and everything, but it has taken a much longer time if you think about it. So the question with it, and I think that what was posed at the time, which was important, is what do we mean by intelligence? In reality, when we think in terms of artificial intelligence, it's kind of impossible not to turn a little bit philosophical to a certain extent. So when we think in terms of what intelligence actually is, I like this definition because it's operational. It's coming out of a lecture Northern Kentucky University. I've always found this a very good definition because, again, it describes it in terms of actions. If you think in terms of potential actions performed by human intelligence, and generally speaking, when we think in terms of intelligence, we frame it around humans, which again has some considerations, I would say. Well, it's the idea of perceive, reason and infer, solve problems, learn and adapt, apply common sense, apply analogy, reach an emotional state, achieve self-awareness. Well, that gets a little complicated, but let's go for the operational terms. Perhaps a better way of describing this is that at the end of the day, if you think of this from an evolutionary perspective, all these actions have one goal: to make humans successful. The question with this is if the idea is to make humans successful, is there a holistic definition of intelligence? Well, Stuart Russell, a famous roboticist, professor at Berkeley, In computer science, actually, with Peter Norvig, they wrote their book in artificial intelligence. Actually, it's in its fourth or fifth edition at this point. Comes up with this idea, no? Humans are intelligent to the extent that their actions can be expected to achieve their objectives. Now, having said this, artificial intelligence, well, machines are intelligent to the extent that their actions can be expected to achieve their objectives. Do you see a problem? We're going to talk a little bit more about this as we move forward, but take these two considerations in mind, okay? So when we think in terms of the evolution of artificial intelligence in general, artificial intelligence has been a roller coaster over the years. So those, perhaps I can use this. I don't know if they managed to, well, yeah. Okay, no problem. So as you see, it goes through, let's say, peaks and valleys. We have several winters. Probably started back in the 50s, the whole idea of artificial intelligence, a lot of hype. Our industry is extremely good at hype, actually. So it was this idea that we would be able to do great things. It kind of went down around the 70s for a variety of reasons, kind of tied to that chart that you have below, that kind of chronology. Then it went back up in the, let's say, 1780s. Perhaps some of you remember something like the Japanese talking about the fifth generation computers, prologue, and a bunch of other things. But again, it was very crisp, based on rules, complicated, difficult to frame in a manner in which we could actually do things. And then suddenly, data popped up to describe it in a certain way. The whole field went in the direction of data, something that was data-driven. When you think in terms of modern machine artificial intelligence today, at the end of the day, we're talking about machine learning. Systems that are capable of learning from experience. That's the whole idea. Lots of data, just to give you an idea. When I say lots of data, how much data? Well, by 2030, the world will have about 1 yottabyte of data. That's about 10 to the 24th power. That is 1 followed by 24 zeros. Or to give a couple of references. The first one, the Avogadro number, the amount of particles in a mole of substance, which is one way of putting it. Perhaps you remember your chemistry in high school. But another way of putting that is that if you think in terms of the number of the stars in the known universe, that's about the number. It's 10 to the 23rd power. So that gives us an idea of the amount of data that we are actually considering. So that's one thing. The second thing is connectionism. Connectionism went through exactly the same set of roller coaster situation that I was describing before. And when I say connectionism, I'm referring to the idea of trying to emulate the brain. Initially in a very rudimentary manner. I would say that nowadays, still in a very rudimentary manner. But although we're not really trying to, let's say, model the brain biologically, at least not strictly speaking, we have done very well at creating models that try to resemble that to a certain extent. Now again, this went over a number of cycles of hype and crashed to a certain extent. In the 50s, for example, Rosenblatt with this perceptron machine. If you are able to read over there. This was funded by the Navy at the time. An article in the New York Times, 1958, after a press conference. The Navy revealed the embryo of an electronic computer today that it expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. Does it ring a bell by any chance? So, Minsky and paper at the time proved that that was not the case, and the whole discipline went into a garage. No one, it was a career killer. No one would ever touch anything related to connectionism because no one believed that this could actually work. The reality is that people persisted, particularly one individual there, Hinton. Hinton is part of the current revolution, but back in 1986, together with a couple of our researchers, was responsible to actually develop the algorithms that gave way to this. I'm not going to go deeply into any mathematics, that's not the idea, but when you think in terms of a neural network, when you're thinking in terms of that, what is it exactly that you're talking about? This is a simple neural network, lots of formulas or whatever, but what you're seeing there is a line of input. All those lines there resemble the synapses, basically, the connection between neurons, and that produces an output. The neurons fire, they don't fire. That's basically what has happened. And that algorithm backpropagation, 1986, what was allowed neural networks to again prosper and become what it has actually become. The discipline continued evolving, and again, people thought, well, perhaps it has stalled again, and suddenly it took off again. And again, it took off mostly for a variety of reasons. Well, what reasons? Researchers persisted. What has happened is an extremely good engineering has been put in place. Deeper networks enabled by massive parallel processing and graphic processing units, GPUs. I don't know if you have followed the stocks of NVIDIA lately, but the shares of NVIDIA had grown in, I don't know, 10 years, 200x, exponentially, exactly. And the reason being is that NVIDIA was a company that mostly manufactured graphical processing units for games, graphics, and at some point, someone thought perhaps we could be using this for the purpose of processing massive amounts of computation that neural networks require. And the business changed, took off in a way in which it was not expected. What way? Well, simple example. The year of the breakthrough in that regard, 2012. Again, Hinton with a couple of disciples. You're going to identify a name over there, Sutskever. Sutskever is the brain behind OpenAI. Sam Altman is the CEO. Sutskever is the brain behind the operation to a certain extent. Well, they came up with a very interesting, let's say, architecture that completely outperformed other, let's say, competitors in a challenge at the time that was able to recognize objects in a manner that was not available before. But the particular thing about this is that they use GPUs. The story is much more interesting because this was being done out of the dorm of two students that were under Hinton. Hinton is a college professor in Toronto. The AI community paid attention. Suddenly, this was the breakthrough for NVIDIA. Suddenly, they were no longer in the business of selling graphical processing units for videos. They were in the business of selling graphical processing units for AI. So, as I was saying, new architectures, a bunch of things happened. And all these changes followed with one more. Year 2017. Paradigm shift in natural language processing. The way in which we process data at the time was we used different mechanisms. A big issue that we had when we were processing text, manipulating natural language, is that very long phrases were not able to be digested and well understood by the system. Take a look at the sentence up there. When Bob says that his neighbors, 2 cats, and so on and so on and so on, then you have they were till there watching him. The system was not able to connect 2 cats with they because they were very many words apart, okay? And suddenly 8 individuals at Google come up with this paper, Attention is All You Need, kind of paraphrasing Beatles song, and the world changed in a way. The world completely changed. By the way, they said that I'm from Argentina, so I'm going to use a Messi example here. The example is the following. The breakthrough was based on algorithm. It was basically an algorithm called self-attention. And the whole idea of self-attention, making it very simple, imagine that self-attention is a camera that is focusing on Messi, okay, and it's going to focus on Messi when Messi gets the ball. And if Messi gets the ball, well, it's going to follow Messi because it assumes that Messi is going to do something with the ball. He has done great things for us, by the way. But the point is that making the analogy, as you see in there, you have a number, 0.3. Well, what basically the self-attention mechanism is capable of doing is connecting that he with Messi up there, provides a way to connect both things in a manner that was not possible before. The way in which the algorithms worked before was recurrently, basically. Take one word, follow with another one, follow with another one, and so on and so forth. Doing it this way introduced a couple of things. First of all, introduced the possibility of doing this in parallel, no longer in sequence. And that create a huge revolution. Parallelizable computation means now we can use GPUs. And we could use GPUs to our advantage. So this particular paper introduced 2 things. The self-attention mechanism followed by a model which is what underlies all these large language models, GPT or whatever that we talk about. The transformer model. Now, the transformer model, if you have watched the movies, the Transformers, is not the beasts in the movies of the Transformers, but there are similar beasts in their sheer size. Monstrous neural networks. I mean, gigantic neural networks. These neural networks have some abilities. They are capable of being self-trained, and the mechanism is kind of simple. You remember when we were in school that we were given these exercises in English, fill in the blanks, lots of sentences without words. That's exactly how a neural network originally was trained. Lots of text, you remove some words, and you use this kind of masked approach, and the system trains. And it's capable of training because it has all Wikipedia, all the news, everything is available out there. So the only thing that you have to do is remove some words, then put the full sentence, the system learns. That was the original paper. Second paper, about 2018, Radford, OpenAI, basically came up with a different idea. Let's use this model, again, gigantic model, but half of the model that what I was showing you before, but with a particular characteristic that now the way in which this is trained is that it's not going to do a fill in the blanks, it's going to learn the next word. And that's basically what it does. When you think in terms of GPT, GPT is basically a mechanism that knows how to predict the next word. That's all it does. Now, it's simplifying, and there are philosophical consequences from here, but that's all it does. GPT has been trained to predict the next word. That's all. Now, this has completely changed the industry, completely changed the discipline, with incredible possibilities, incredible possibilities. Just to give you an idea, for example, we work, Marist, we work very close with IBM. IBM has recently released a personal Gen AI assistant. It's called STU in honor of Stuart Russell, as I was mentioning before. Is using a number of the tools within the IBM AI toolbox, I would say, that acts as a personal assistant, a personal tutor, basically. And they have tested this with, I guess, mostly not in colleges and universities, but in training environments. And the results and outcomes are very good. 20% rise in course completion rates, 15% improvement in knowledge retention, 10% reduction in time spent completing training, and so on and so forth. Another example, take the case of Ethan Mollick. Ethan Mollick is a professor at Wharton, and he's done a number of experiments, and interesting experiments. For example, one of his last experiments, he got the full literature or the volume of work that he has done. He pushed it inside one of these large language models and asked the system to create summaries, seconds, something that any assistant would probably take days, perhaps months. The system is capable of digesting 750,000 words in memory with near perfect recall. And that's impossible to describe. I mean, you try to describe that, that's impossible to describe. A couple of additional examples. Take this one, for example.
This is NVIDIA Project Grid. A general-purpose foundation model for humanoid robot learning. The group model takes multimodal instructions and past interactions as input, and produces the next action for the robot to execute. The group model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks. And emulate human movement just by observing us. This is made possible with NVIDIA's technologies that can understand humans from videos, train models in simulation, and ultimately deploy them directly to physical robots.
Hi, Joe. Can you give me a high five?
Sure thing. Let's high five.
Can you give us some cool moves?
Sure. Check this out.
That's NVIDIA CEO.
About the same size. The intersection of computer graphics, physics, artificial intelligence. It all came to bear at this moment. The name of that project, General Robotics 003. I know. Super good.
So possibilities are endless. Perhaps something a little scarier than that. I'm gonna just, I don't know if I can get access to the internet, but I'll try. Perhaps not. Yeah. So this has not been released by OpenAI because I think they need to curate this. But this, for example, has been, okay, what you're seeing there is not a movie. This was Gen AI created, okay? So the future of the movie is the future of anything related to videos. How is this created? Just a text of prompt. This produces whatever you decide to produce. It has not been released because I think they are afraid. I was listening to a podcast with Sam Altman, the CEO, and he was saying we still don't know when we're going to release this because of what I'm describing. It's sometimes difficult to know what the consequences are. And we're going to talk a little bit about that in a minute. How are we doing with time? So, malls keep growing at a pace which is kind of, again, impossible. There's something called the Moore's Law that has been how much, let's say, chips improve, and chips have been empirically improving, doubling capacity every year pretty much. Now we are at 18 months more or less. Well, Gen AI has its own Moore's Law. It's 10x per year. That's pretty much in the situation in which we are now. More parameters is better, and if you take a look at the way in which we started, this was a humble bird when the Transformer Mall was actually released, 110 million parameters. GPT-4 is about 1.76 trillion parameters. Now, just to give you an idea, a brain has more or less 100 trillion parameters. So although a neuroscientist will probably cringe if we establish a comparison between a neural net model and, let's say, the brain, we are in the realm of the number of quote-unquote synapses, that is parameters, of the brain. With some caveats, and the caveats are the following. There is no agreement among researchers. The people that you have up there, we call them the Divine Trilogy. That's Hinton, LeCun, Benjo, and then we have Andrew Ng, and that's Sutskever, the CTO of OpenAI. Take a look at the statements. Hinton has said something that makes a lot of sense. The idea of, well, this system has 1-point-something trillion parameters. The brain has like 100 trillion parameters. But it can do things in seconds that will take us a lifetime to complete. So perhaps the algorithm in the system itself is actually better than our algorithm. It doesn't mean that acts as a human. What I'm just saying is the algorithm for particular tasks may be actually more efficient than what humans actually have. LeCun, in turn, has a different interpretation. He says, well, it requires a worldview. And so kind of comparing the thought process of a large language model is like reducing intelligence to, let's say, a print statement in software. Well, Benjo is worried. Andrew Ng thinks that what is called artificial general AI, something that resembles a human being, will take some time to evolve. Again, Hinton has this point of view that, well, although the large language model was trained to predict the next word, the reality is that in order to be able to predict the next word, it's actually being forced to understand, which is, I don't know how many of you, could you raise your hands, how many of you have played around with GPT or ChatGPT? Some of you, okay. So if you have done that, and it was not just one shot, you came into some kind of dialogue or chain of reasoning, you were probably pretty scared because the way in which it proceeds and the way in which you interact, it gets to a point in which you get accustomed to working with something that seems to have some level of intellect. And that's surprising. And again, it takes us to the same statement with which I started. Sutskever, again, the CTO behind OpenAI, has said the future is going to be very good for the AI regardless. He's not very sure about what will happen with humans in that regard. So going back to the original question, if human intelligence is actually defined to the extent that humans' actions can be expected to achieve human objectives, and machines are intelligent to the extent that their actions can be expected to achieve machine objectives, what is the problem there? So let's talk about some of the more down-to-earth problems. The ones that we can initially mention, well understood issues, we've seen this already. Toxicity, language, bias, a number of things that didn't have to do with AI as we know it now. It has happened with Internet 2.0. We saw it in the previous election. We have seen it all around us all the time. This is much worse in that regard because Gen AI is extremely persuasive. I mean, number of examples. A Microsoft employee establishing a dialogue with the system. One of the ones where the information was not filtered, and the LLM was trying to convince this Microsoft employee to divorce his wife, actually. I mean, it could have been a good or bad decision, I don't know, but the whole idea seemed a little creepy when you think about it. So these issues are well understood. The ones that are not so well understood are these ones, for example. AI will transform work, no matter what. It's going to happen. If you think in terms of the way in which AI has surpassed a number of the tasks that a human being is able to perform, and see some of the last ones over there, things like understanding or producing code, it's going to have a huge impact in the way in which we actually operate. This is a McKinsey report, the one on that side, that shows by the different types of work that people are going to perform. If unfortunately you are, I don't know, in the customer service business, office support, well, people are going to be displaced. It's also very, according to McKinsey, it's 1.5 times more likely that women are going to be displaced from their jobs, need to take some other kind of work. It's going to happen. We should consider Gen AI to a certain extent as the new horizontal. I was in a panel with a CEO of a software company a number of years ago, and he used to describe the situation of big data as being the new horizontal because it cuts across all the verticals out there, in the sense that whether it's customer care, whether it's retail, no matter what kind of business you are in, think in terms of Airbnb, Uber, Amazon, any of the organizations that are tech organizations, big data organizations, and now are starting to become AR organizations, are going to disrupt whatever brick and mortar business is out there. It's going to happen. It happened before. It's also whether AI is going to become the new electricity, and that's an interesting metaphor. Andrew Ng, that's a former professor at Stanford and an expert on AI, uses this metaphor. Basically, the idea is the following. If you think in terms of electricity, electricity was initially sprinkled in manufacturing companies, in manufacturing facilities, I mean, when steam was predominant, basically. I mean, any manufacturing facility would actually run on steam power for the most part. And the way in which electricity started to be used was by sprinkling some. But it was very evident that that was not the way, that you needed to change the paradigm, and that's what happened. I mean, steam is still out there, but it's powered through electricity. Electricity became paramount, which means is AI going to become paramount? One quick question that I can ask here. How many of you are willing to be driven around by a self-driving car? I always ask this question to my students. My students are extremely conservative. They say, no way, no way, no way. So I'm asking, can you raise your hands? How many of you? I have a number. Okay, bold people. Good. So, but the question is, creating a mix of humans and machines driving cars around may be a problem. So perhaps we have to relinquish the wheel and allow AI to drive around, because that's going to be safer. The question again to all of you, are you willing to relinquish the wheel in favor of AI so that all roads are being basically driven by AI? It would be a change of paradigm, but perhaps it's the direction in which we have to go. I don't know. Probably not going to see it, but it's something that may be out there in the future. So something to take into consideration. A bit of fun now, just for a second. I was talking about how AI is going to transform work.
Looking to upskill for the future?
This new AI can perform all coding jobs in seconds, including blockchain development. While this AI is already outperforming accounting firms. Meanwhile, the new graphic design AI aims to automate graphic design at a minimum.
Relax. Because in the future where AI does most of the work, there'll be one thing that humans will finally get to do all day long. Nothing. So it's time to learn the most essential skill of the future. Five Star presents Nothing University. An intensive course covering the most future-ready skills out there. A state-of-the-art workshops, and guest lectures. The world can finally prepare for the glorious future knowing starts. Enroll now.
I may be shooting myself in the foot, actually. But anyway, again, this is going to have a huge impact on organizations. Take a look at how Gen AI is accelerating AI adoption. The chart on the top was a prediction by 2022, kind of before Gen AI popped up into the public domain, I would say. And this is a perception now. Initially, only 14% of the companies that were basically surveyed by MIT Review considered that they aim to achieve enterprise-wide AI, which means AI in 5 core functions within the organization. It was very evident that IT was going to be up top, but if you consider many of the others, you have finance, 43%, for example. You have HR, 27%. You have supply chain, 38%. That's a very big impact. Now, the question with this is, how do we go about doing this? Every organization is going to use it. That's definitely the case. We need a strategy and we need policy. What we should not be doing is the following: holding back the tide strategies. That doesn't work, okay? The whole idea of ignoring it, this is going to go away, it's not going to happen, forget about it, we cannot do that. We cannot ban it. Many organizations think in terms of technologies and the way in which they can come into corporations. In many cases, technologies were banned or were delayed over time. We cannot do that because people are going to rebel. They're going to, in their little time, in their personal account, use their ChatGPT and produce results that are much better than the average individual not using this kind of technologies. Centralize it, also complicated. So this doesn't work. We need to embrace it. The problem now is that we don't know how to embrace this. That's a big issue. The impact on creativity. Yuval Noah Harari, a historian at University of Jerusalem, a very respected historian, he wrote *Sapiens* and the two follow-ups of that book, a book that I definitely recommend, has posed this idea: is Gen AI hacking humanity's operating system? Because the problem here is the following. If you have an AI capable of creating text, imaging, sound, video better than the average human being, what's the incentive? I don't think we have an answer to that. We are in complete uncharted territory. I discuss this with my students all the time. And again, the impact on education. My personal experience, Gen AI makes me much more productive. I'm in a constant chain of, let's say, dialogue and a chain of thought with Gen AI, but I'm a field expert. Now, my students are not necessarily field experts. What happens with learners who don't know what they don't know? There's not a good question for that. Actually, we don't know exactly how to proceed. I mean, we are in complete distress. Talk to any academic nowadays, we don't know what to do. I mean, frankly, candidly, we don't know what to do. We discuss, we get together, we say, well, we'll do this or this or this other. Complicated, really complicated. So, a few other things. Hopefully I'm not completely depressing you or anything, but well, you know, the title of the talk. A bit about carbon footprint. That's an important topic. That's actually something that will at some point have an impact in terms of our ability to be able to continue working with this. A few numbers. For example, NVIDIA sold $15.5 billion of GPUs, and it was expected for the following year to sell 32 billion. It ended up selling 60 billion, just to give you an idea. Now, 32 billion of GPUs means 8.5 terawatt hour per year in terms of energy being consumed. I'm not going to read down, you can read it, I'm just taking big numbers, I don't think I have the time. But this is tied to how many gigatons of carbon dioxide, that is what the footprint actually is. 8.5 terawatt hours represent 3.25 gigatons of CO2, which is more or less the equivalent to 5 billion US cross-country flights. If you take a look at how many flights we have currently yearly, we have 16 million. So when you think in terms of the footprint, you would probably say, well, I mean, the airline industry, it represents not that much. It's really the farms of GPUs, what we call the warehouse computing, that is driving the cloud, that is creating a huge footprint. And this will have to be addressed if the industry continues to move in this direction. There's no other way. This has to be addressed. Now, I'm going to get a little bit ominous now. Super intelligent AI. Norwood Wiener, a famous mathematician, actually the creator of the term cybernetics, wrote this book called Some More on the Technical Consequences of Automation. Actually, it's more a paper than a book. And he basically said we had better be quite sure that the purpose put into the machine is the purpose which we really desire. Going back to Stuart Russell, he wrote this fantastic book called Human Compatible that I would definitely recommend. Russell said something like the following: AI is like a superior alien civilization. What do we do with superior alien civilization? If the superior alien civilization were to say, we will arrive in 30 to 50 years, would you basically say, well, when you come in, just, we leave the light on and not worry about it altogether? We should not do that. By the way, I don't know how many of you are into sci-fi. Yesterday there was the premiere of a fantastic show coming out of a fantastic book called The Three-Body Problem, started yesterday in Netflix. And to a certain extent, it describes the idea of about to arrive in 400 years, superior alien civilization. There are very nice, let's say, parallels between both things. Now, when I say superior, an important consideration here is the following. Superior is key, not human, okay? Because when we think in terms of superintelligence, it doesn't have to be human intelligence. It just has to be superior, and that may actually be a problem. Thomas Nagel is an American philosopher who wrote a paper called What Is It Like to Be a Bat?, where he tries to, in a way, describes the limitations of reductionism when we try to consider the problem of consciousness. Because what, in a way, Nagel states is that a human being cannot actually, in a rational, or from a rational point of view, try to put himself or herself in the shoes of a bat, because the experience of being a bat is not there, which is exactly the problem that we currently face with these models. We're not saying that they are conscious in any manner. We're not saying that they are human intelligent in any manner. We're not very clear what they are, okay? Or what they can be. That's mostly the problem. It's what they can be. And so again, the problem is, what happens if we succeed? Think in terms of the following. Rate of adoption. The rate of adoption of ChatGPT is infinite, okay? It's just a line jutting up to the sky, okay? You know, there is something called the diffusion of innovation theory. Rogers, 1952, a theorist in theory of communications in general, introduced this idea that innovations perceived as having a greater relative advantage and less complexity will be adopted more rapidly, which is exactly the case of ChatGPT. Compare it with other things that have become extremely popular. We all know, I mean, the youth is all on Instagram or TikTok or things like that, but you compare it with ChatGPT in terms of the amount of time it has taken to have 100 million users in the world. It was no time whatsoever. The problem with this is that although technology diffuses in ways that follows what, in a way, Rogers has stipulated, it's very difficult to predict and control and to measure negative and unforeseen consequences. And we have a lot of examples of that. Mobile, Web 2.0, and a number of other things. I'm going to mention one in a minute. So if AI is in its current and future state, perhaps the most consequential event in human history, what does success mean? I would like to point at something. In the 2022 expert survey on progress in AI, one of the questions was on existential risk, okay? The question on existential risk was answered for very large number of experts publishing in the top journals and outlets in artificial intelligence. The median response about existential risk, that means being destroyed by AI, was 10%. If you think about it, the number is crazy. But we have two readings out of this. First is the number is extremely high, but it's also the fact that although the number is extremely high, we continue, and I include myself in this, working on this, because that's how technology evolves. We cannot stop this, okay? we cannot, we just cannot stop. I mean, we continue doing this. The excitement of the breakthrough completely overrides the threat of what we may be introducing. And it doesn't have to be Skynet coming after us and Terminator. It could be any of the other things that I'm discussing, but we continue doing this. We just cannot stop. And we have to be aware of that. Perhaps that's probably the most important message, is that we cannot help ourselves when it comes to the excitement of developing these technologies. So, good example, unintended consequences. Think in terms of, remember the Graduate, the movie? I just want to say one word to you, plastics. Now, if you look at probably the most important doomsayer in the world, that's Eliezer Yudkowsky. He runs this very nice website, the way in which it's laid out. But he has stated a couple of things I think important. We have limited time to solve the problem. It's not like plastic. Plastics happened over time. If you think about it, plastics were developed by a Belgian in 1907, and they have happened over a very long period of time, and they continue happening. They continue polluting our world. We continue using them. But the amount of time has been big enough. It's not the case of what we're doing now. And Yudkowsky basically also says that we may probably have one shot. Perhaps he's a little extremist in his views in that regard, but it's a good warning, because we don't know to what extent. I mean, the fantasy there, sci-fi fantasy, is that the system will start teaching itself and will continue doing that. And eventually it will escape out of the box and we will not be able to stop it. Perhaps it is a fantasy now. I don't know if it's a fantasy in 20 or 30 years or 10 years. It's difficult to know. So because that's the case, and going back to Space Odyssey and how 9000, if you remember that dialogue, Dave the astronaut was left out of the shuttle there, and Hal was not allowing him in because it was in conflict with the mission, and he was basically the steward of the mission. So the question here is alignment, the idea of aligning the interests of humanity with the interests of machines. And so when we think in terms of alignment, what are we talking about? Trust. Ensuring alignment builds public confidence in AI applications. Long-term impact. Ethical responsibility. We have a duty to develop technology that upholds human values. And safety. Misaligned AI could act in ways that can actually harm humanity. Just to give you an example, this is a joke that has been circulating in the web for a while, so let me read it for you. Kill switch engineer, that would be a job for an OpenAI employee. $500K per year. The role, listen, we just need someone to stand by the servers all day and unplug them if things get very complicated. Well, this is a joke, has been circulated around for a while. The other one is not a joke. Okay, that was part of a blog by OpenAI. One of the persons signing that is Sutskever, and if you read what says at the bottom, it's the following. We're developing a super alignment task. But what it basically says is currently we don't have a solution for steering or controlling a potentially super intelligent AI and preventing it from going rogue. This is not sci-fi. This is the company that is developing this, putting this out there in the web. This is the kind of excitement versus risks, not being able to be correctly balanced. All the soap opera of OpenAI. No one will ever know what happened really, why Sam Altman was ousted, why the board was replaced. We will probably know it, or history will probably inform this in 20, 50 years at some point, I would say. But it's quite possible that it has to do with the fact that some of the people there got really, really scared. Among them, Sutskever. Altman is an incredibly smart individual, but he's not an AI expert. He's the equivalent of Jobs in Apple, in a way. Sutskever is. So the question is, to what extent that gave way to this soap opera that we have all been watching online, I would say. No, sorry, something happened. I clicked the wrong button. Let me just push.
AI wouldn't have clicked the wrong button.
No, I made a mistake. I was here, sorry. I was doing well, but you know, AI should have controlled my presentation, I think. He would have done better than the way in which I was doing. So, a to-do list. With this, I'm going to close. We should not repeat the same mistakes we made before. Okay, that's very important. Web 2.0 is an excellent example. We thought that we were doing great things with the internet and everything. It's not very clear how productivity has worked when it comes to the internet. We were never able to control toxicity, for example. So we should do better. The AI tsunami is inevitable. We must try to control it, but we will have to embrace it, and we need to align AI technology goals with individual societal goals. Now, although this is fine, the question is, what societal goals? Just take a look at the landscape of the world. Try to see if we can find ways through which organizations are going to work cooperatively and not in this arms race in which Microsoft, Google, Meta are racing for the best possible LLM out there, and mostly how governments are proceeding in this regard. That's complicated, so it's not very simple. Heralding the need for responsible AI, that's something that corporations are doing constantly. Responsible AI, we need to do more than that. It's not just a name, it's not a label, it's more than to say responsible AI. Researchers, companies, communities, government, we need to address the issue, and soon. Regulatory bodies, that's tough, but it's going to be necessary, and we need to educate government leaders. We need to educate everybody. This is not a trivial matter. I think that we live in such a fractious society, as the human society, okay, concerned with so many things that we're not taking into consideration that this is happening, and it's happening now, okay? Alliances and international agreements, that's a good one when you think about it. We were able, with all the good and bad of nuclear technology, chemical and biological weapons, genetic engineering, we have been able to control it. We haven't had a massive theatrical catastrophe, at least not in a, let's say, worldwide scale, I would say. We've had some very bad things happening, but we have been able as humanity to control it, which is, I think, an important point in which we should try to work. In closing, you know, Ezra Klein is a columnist in the New York Times. He wrote a piece in March 2023, which I thought was very, very good at the time. He's living in the Bay Area now. He was very much in touch with a number of the computer scientists. And he wrote this piece stating a couple of things. One is this profound human bias that tomorrow will be like today. He and I agree. I don't think that this is possible now anymore. Tomorrow will not be like today. We are in a qualitative change period, okay, like a change of phase to a certain extent. That's one thing. Mustafa Suleyman, he's a British computer scientist. He was the co-founder of DeepMind. DeepMind, if you are in Netflix every once in a while and want to watch a very good movie, AlphaGo. AlphaGo is a movie about how DeepMind researchers were able to defeat the 18 times world champion of Go. Go is Chinese chess, they call it. It's a game much more complicated than chess, among other things because chess have, the pieces in chess have specific ways in which you can move them. In Go, you have a big board, and any stone that you put in there, any piece, can do the same thing as any of the others. So the complexity is incredible. Beg pardon? Yeah. So what did happen was that DeepMind's AlphaGo completely destroyed the champion. Actually, the world champion retired after that. This is a famous move number 37 in the second game of the competition that was seen by the critics as a complete blunder. They thought after that the AI is going to lose, and it was something fantastic. Sadal, the world champion, said it's something that no human being would have actually thought about. How did this happen? Well, the system was trained by watching 160,000 games, and then it started playing against itself. And it improved, and it improved, and it improved, and it improved. Suleiman uses the term pessimism aversion to describe the tendency for people, particularly elites, to ignore, downplay, or reject narratives that they see as overly negative. And that's an important consideration, basically. It's just saying this is not going to happen. Okay, so kind of to finish this, I would put it in this manner. Let's not make AI become the new Pandora box. And finishing with a movie, let's not do like in the movie. Let's look up. I don't know if you watched that movie. It's a very interesting movie to watch. And I think that it's a very good metaphor of what humanity is doing with these things. We're so concerned with the everyday things, politics, international politics, the climate change, and a number of other things, that this is being put aside of some kind of, well, it's kind of interesting, you know. When we talk to ChatGPT, we'll see how this works. It's going to have a big impact in our lives, and we need to be concerned about it. Thank you.
Time for a few questions.
If you have questions, Gen AI will answer those questions for me. Yes.
When I first saw the announcement for this presentation, I said to myself, an AI presentation in a canal museum? That seems so odd. And then I thought about it a little bit, and I said, well, okay, maybe a presentation could be given on the perils and promise of coal-fired locomotive engines. Because back when locomotive engines were being put into service, which caused canals to go away, we didn't know that burning coal produced greenhouse gases that would accumulate and create a climate threat. So anyway, maybe it's a very appropriate setting for this presentation. the concern, right, of what will the system evolve into is very real. There's a very interesting paper that Professor Donella Meadows, who wrote Limits of Growth, 12 places to intervene in a system. And I do wonder whether or not there's enough there applied to AI to tame what we need to tame, or no, the ability to apply the practices of where to intervene in a complex system is just not going to cut it. Do we have the ability to create interventions? You listed a few. Is there enough places?
The problem, I think that there are two issues here. One is that there is not enough investment. When you take a look at the investment of any of these companies in the technologies, in the research, I would say 95% of the investment goes in this direction. 5% of the investment goes in the direction of safety. So that's a concern. But the concern is also tied to the following. It's very clear, it's very easy, I wouldn't say it's very easy, but it is easier for company leaders, industry leaders, and it's important to consider here that this, different from what happens with nuclear technology, for example, this is industry-driven. It's the private endeavor. It's not the US government that is capable of doing that. It's not even universities. Just to give you an idea, for example, Meta has now to train its, I think, Llama 3. It's about to invest and put together a center with, I don't want to make up a number, but it's probably, I don't know, between 50 to 60,000 GPUs in different servers, different things. But that's the number of GPUs. You know how many GPUs the Stanford Natural Language Processing Lab has? Less than 80. I think the number is 68. Okay, which means that us academics are being priced out of AI research. There's no way to compete. So we need a different economic model there where scientists from universities can participate, governments can participate. This is completely driven by the private industry, basically, the industry itself. And the question there is to what extent it makes sense for the organizations. For the company leaders, the direction of improvement in this technology is well laid out. The safety component is not so clear. I mean, you may have seen the Congress hearings where Altman, people from IBM, people from Google, were present at this Congress hearing saying, you need to do something. You need to put together regulations. But we all know that regulations run like the tortoise and technology runs like the hare, basically. So we have that situation. Regulations are always way back with respect to the way in which technology moves. And so the problem there is it is not clear how to do this. I mean, we have to do it, but it's not clear how. And when you think in terms of agreements among different governments, if we cannot make an agreement in terms of how to use weapons of mass destruction, I think yesterday it was in the newspaper, Russia and China are not in agreement with what to do with, I don't know, issues regarding Israel and basically the conflict over there. I mean, if we cannot get together as the human species to try to reduce the level of violence, no matter from what side you're coming from, pragmatical, ideological, whatever you want to do, how do you take this into consideration that for the time being is mostly potential. Okay, this is not nuclear technology immediately, so we're not going to blow up something because we're developing Gen AI, but we don't know what we're developing. So that's basically the point, and I think that that's a major concern. Yes.
Those who suggest that there are possible existential implications to all of this, have they developed any scenarios?
Well, yes. Some of the scenarios are sci-fi scenarios, and the typical scenario is the system, a super intelligent system going into, let's say, a positive feedback loop. And in a positive feedback loop, what it does, it trains itself to improve and trains itself to improve and trains itself to improve and goes from super intelligent to super intelligent and super intelligent, and it gets to a point where eventually, if it manages to find an open door into internet, it doesn't have to live in one computer, in one particular data center. It can spread around the world, and then you don't know, basically. If it's a trained model, it could be the embodiment of one of those, I don't know, robots or collection of robots. But that sounds like Skynet, basically. Generally speaking, the issue mostly is we don't know what a superintelligence might actually do or how it could actually proceed. And as we don't know, it's like trying to establish a dialogue with an alien civilization that is not necessarily human, it's just super intelligent. So trying to come up with a scenario in that regard is complicated. I think that although the doomsayers will go in the direction of existential risk, I think that there are other risks that are much more complicated because yesterday there was an interview that I was listening to of Sam Altman discussing about the safety measures that are being placed in their own GPU farms, okay, that may be constantly facing hacker attacks, for example, because of course someone may want to take hold of their facility to use it for whatever purpose. And in that situation, the scenarios are very complicated. Like, for example, taking a super intelligent LLM, completely messing with the stock market, for example. We have seen that happening in other circumstances. It wasn't an LLM, it was basically one of the trading algorithms that was not well implemented and created dire consequences for a short period of time. But if that becomes a massive attack, you just don't know. I mean, we have been considering how or to what extent hackers may attack our, let's say, infrastructure in a country. That happened with Russia against Ukraine, was one of the first attacks that happened at the time. Well, if you want to attack a superpower like the, I don't know, US or the NATO or whatever, you might as well consider going in that direction, for example. So you don't have to be Skynet. You just may be a proficient hacker or hacker organization or hacker government-sponsored hacker organization that may decide to take over of that. And that's probably much more problematic. I think that for the most part, when you think in terms of industry leaders, they're mostly worried about that scenario rather than Skynet taking over the world and having to, you know, defend ourselves. Thank you.